In this experiment we're going to investigate Fleming's left-hand rule, when a wire carrying a current in a magnetic field will experience a force. To see this more clearly, we'll use a wire which is hinged that can swing backwards and forwards in the magnetic field between the north and south pole of a C-core magnet. Pressing the push switch completes the circuit, allowing a current to flow. This current flows to the right in the wire that's in the magnetic field. Here the north pole is at the bottom and the south pole is at the top. Switching on the power supply and completing the circuit, you can see that the wire experiences a force towards us at 90 degrees to the field produced by the magnet. If we look at that more closely with the arrows to show the directions, the field is vertically upwards, and when the current flows to the right, the force is then towards us. We'll just check that with using our left-hand rule, with the first finger pointing upwards, the second finger pointing to the right, and our thumb is then pointing towards us. By changing the direction of the magnetic field, here I'm turning the magnet over so that the field is now pointing vertically downwards. When the current flow is still to the right, you'll see that the force is now in the opposite direction, away from us. We can check this with our left-hand rule. This time the field is pointing downwards, showing that my thumb now points away from me in the same direction the wire experienced the force. Having replaced the magnet to the original position so the field is pointing upwards, I now change the direction of the current. With the current now flowing in the opposite direction, you can see that the force also is now away from us. Pause the video and check that that's still correct with the left-hand rule.